Our final presentation in the digital engineering, digital transformation track is from Mr. Tom McDermott, who is the CTO of the CERC and also a PI and researcher and good friend. So we like Tom, be very nice to him and also ask him hard questions because it's funny. Joining us for the presentation today are also our sponsor, Ms. Nadine Geyer, who's the Director of Systems Engineering for OUSD R&E, and Dr. Kelly Alexander, who's the Chief Engineer for OUSD R&E. So welcome and look forward to your talk. Thanks, Tom.
Great, thanks. So I'm going to kick it off and then Nadine's going to go through a few slides in here. Kelly Alexander, who's the project manager on the government side, is sick today, so she's watching from TV land, I believe. We'll kick this off. And so the first thing I want to say is this is a government CERC integrated product team working through this process. So we have a government team that's led by Nadine and Kelly with Mo Afori and Ed Mashinsky and then Mike Kuber, and then we have DAU on the government team. So Rob Reagan from DAU has been working the workforce side of this with us. And then we've collaborated across a number of different researchers and students at Stevens, at GTRI, at Virginia Tech, at Alabama Huntsville, and Penn State. So none of these people are full-time on this, but we've had a whole lot of people thinking about this idea of system engineering modernization. What does that mean? So that's the kind of the process that we've gone through. So I'll turn this over to Nadine up front, and she'll talk about the government aspect of this program in the first couple of slides. Thanks, Nadine.
I know we're keeping you from the drinks and the reception, so I'll try to be brief. A couple of years ago, I was approached with the goal of, and this is how it was put to me, we need to bring systems engineering from the 1950s to the 21st century. That is a very broad goal. It took a little bit to come to define a problem statement that was acceptable to the higher ups. And it also then, I have this philosophy where if something can't be practically done then and have a practical use, then I'm not really that interested in doing it. So how can I define this down to something that actually can be produced? And in the terms that the UK use, how do I get this so I'm not boiling the ocean? So the problem statement that you see up there is the one that was accepted by my command as the appropriate problem statement for this issue. We then boiled it down to cross-cutting enablers, and then we had our focus areas. Now, if you notice, systems engineering crosses a lot more boundaries than we talk about in just the 4 focus areas that we listed up there. That is on purpose. We cannot cover every single aspect of systems engineering and still produce something in the short term anyways. There is long-term goals of adding in other disciplines and other areas that systems engineering touches, but we wanted to start somewhere. And this is the arbitrary and my decision of where we're going to start. So we're starting with these subject areas first, getting the process down, getting the information down, and then we will expand after this to other areas. Arrow keys? Yeah. Okay. So our current state of systems engineering was also defined over the course of time, and we wanted the ultimate goal of the systems engineering modernization effort is not to change, although we are looking at changing how systems engineering is taught at DAU, but not to change how it's being taught at universities. It's not to change the whole discipline. The goal of this is how do we interconnect these different areas of excellence together for an overarching systems engineering discipline change. And what I mean by that is there are areas that are being improved right now, MOSA being one of them. Mission engineering is being modified. digital engineering is being modified, modeling and simulations being modified. They're stovepiped, however. They're stovepipe and improving their particular area, which is fine. But who is stitching all of this together? Who is making sure that it flows from one aspect, from the concept to all the way to the disposal of that acquisition system? And that is what I felt that we could have real value in adding to that knowledge base. So that is where we're going with this project. And that is where Tom is helping us first off. Well, he'll go through what he's researched so far, but the first research, and then the next part of the research is the roadmaps of how do we get from point A to point B. I think that was it. That was it?
Yeah. So I'll cover this.
Okay.
So this just kind of gives you a snapshot. So we entered this project with interviewing a bunch of people from disciplines and program offices. We talked to the people that own software and the people that own MOSA. We talked to a number of program offices. We ran a series of workshops, one in December of 2021 for Phil Zimmerman, one with INCOSE. This is a snapshot from the INCOSE workshop that we did, 2 of them with them. That gives you some of the ideas of why we're interested in system engineering modernization for the future. So we lack integration of engineering and other competencies across the systems that we build. And the cure for that is really seamless interoperability integration of all engineering disciplines into a common platform. You know, that's the dream state, right? How do we get there? And that's sort of what this project is looking like. And you can go down this list through a set of outcomes: greater digital engineering, continuous engineering, twins, DevOps revolution, and system engineering. All these things were articulated in these workshops. But when we got down to the point of how are you going to do this, it was like blank stares from most people. Some people are doing pieces of this, others are not. And so we really kind of struggled in the beginning to figure out, well, what exactly needs to change and why modernize? And so that led to a set of activities that we did. The output of these workshops and interviews was a set of pain points, the things that are preventing us from doing modernized SE today. And so you'll see in a minute, we organize those as a causal map and a fishbone style chart. That's aligned to a set of lines of effort, which are things that we can do to inform the community about what needs to change over time. And so, you know, the body of knowledge and community of practice, not just for digital engineering, for instance, but for how that relates to system engineering. That's a kind of a new area. What's the policy and guidance, and how's that affecting what we do? What are the model-based artifacts? So, you know, one of the early answers was, well, we just need to make sure we get to the point where we can have digital artifacts instead of paper ones. Well, that turned out to be a dead end because the artifacts don't change very much. There's a whole lot of new ones that come into play. So that drove us. You know, what's the workflow going to look like in system engineering as we get more digital and all these other kind of things, and the thread? And then what are all the workforce implications of that? And so we've really it's been great to have DAU on our team because we've been able to sort of look at the current and future state of the workforce at the same time we're doing this project. So each pain point then will end up being lines of effort and roadmaps. Our task and the CERC was to build an integrating framework that incorporates these activities across all the focus areas and cross-cutting areas that Nadine mentioned. How do we align and integrate system engineering practices to those in the acquisition environment? So we're talking about system engineering, but we're also talking about how the DoD uses it to do acquisition. It's a fundamental part of it. And what are the lessons learned? What are the artifacts and metadata associated with that information or that body of knowledge that our program offices need to have? And so as we developed this integration framework, you know, we realized that the mental models that have persisted from the 50s and into the 2000s aren't right anymore. We have to develop a new mental model of what this looks like, and it really caused us to a struggle. And so I'll walk you through some of that process. I'll mention first that we have a whole bunch of projects across CERC and ERIC that we were able to tap in onto. So one of the really nice things about what we've been able to do here in CERC and ERIC is we've got different projects that are touching all the different aspects of modernization in acquisition and engineering. And so all of thanks to all the people on these other projects, because they've informed a lot of this work. So what are these pain points? They're causally related. They're derived from workshops. They're using this integration framework. I'll talk to you, but really that it evolved to address what we call the slow uptake of modernized system engineering in program offices. It's not that nobody's doing it. It's not done widely yet. And it's not that nobody's doing MOSA or the pieces of this, but they're not well integrated yet. So this uptake is our big problem. And so we captured that into a fishbone diagram, and I'll talk to you why this, but the goal of seamless and efficient digital flows became the motivating factor. So this is an eye chart. Actually, you can read it on this big giant screen, so that's a good thing. Don't usually get to do this, but if you think of the goal, which is the entering the back of the fishbone, is seamless and efficient digital flows of system engineering. That's what we want to get to, and I'm not sure that's what people were thinking when we started this project. They were thinking authoritative models and data. So that's the goal. On the other side of it, it's why is the uptake happening so slowly? So there's a lot of good pilot programs, but there's not a lot of programs, right? They're still all pilots. And so we were able to build this fishbone in these 4 areas. So starting on the left, I'm gonna have to pull out my glasses so I can see it. Adoption, slow adoption. So what are the ways and means to drive adoption? And so we're finding out that we lack not well-defined acquisition processes, but well-defined integration across processes. MOSA is completely separate from digital engineering, but they're the same thing. They're system engineering, right? But all of the ways and means and the understanding of that's coming down separately. So there's a whole lot of attributes that came out of that process. On the flip side, we don't have the policies that incentivize the program offices to do this. Where's the resources? Where's the funding? You know, this is driving slow uptake. You know, we kept talking about we need a big war in order to cause change to happen. So we actually have to do really rapid agile systems before we can be rapid and agile in our systems. So we're not seeing that. That feeds down into this next phase, which is sharing lessons learned. And you know, we have a big problem now on these lessons learned. We don't have good use cases for upstream and downstream use of models. You know, how do they get from the development to the test, or how they get back from test to development? So we don't have enough examples, and we lack clear understanding of what that means in terms of measurement. What's the return for this? And so the separate project on the measurement model was helping this. So we've got to work that, and part of the goal of this project has been to build that body of lessons learned knowledge. As you move on down, we don't have modernized system engineering technical review processes yet. If it becomes our normal workflow, it'll get to be more normal. But as you saw in the last presentation, you know, we don't really know how to do model-based technical reviews yet. People aren't trained in that. So as part of that, you know, we have this fundamental problem that came up when you start thinking of who those models and data that we're reviewing, who owns them, right? Is it the program office? Is it the portfolio manager? Is it the test program? We don't have any clear understanding of who actually owns that stuff yet, but that's evolving in the services. Down on the flip side, we're still describing system engineering as the age-old, what you call major capability development process. We're still describing, even when we talk about the different system engineering, we're still linking it to big program milestones, not agile milestones. We're still linking it to this idea that we're going to start with requirements, even if we're starting with a prototype, you know, all these kind of things. The language still is legacy system engineering, and so we need a new language. And then at the last end, we don't have reference implementations. We have Cameo in the cloud for a program office to use, but digital engineering is hundreds of tools that have to be integrated, or at least tens of tools, and the tools that you choose are going to vary based on the system that you're building. And so it's not a matter of picking one and everybody using it. It's how can you, a program office, stand up their necessary infrastructure. And the result of that is we're not understanding the tool flows. Every program office has to do itself. And the flip side of that is that we don't know how actually to share these data and models because we don't have good interoperability understanding, right? We haven't done the research that says, here's how you connect common data into common model sets, and here's how you design models that are useful and can be reused from one program to the next. So there's just a whole lot of pain points that are in here. I'll note that everything we highlighted in yellow is a workforce issue. So we talk about workforce and culture as like that was a thing, but there's actually a whole lot of workforce and culture issues that have to evolve in here. So this was a big output of phase one from talking to the people. The other thing we did is we looked at all the policies, and we actually put a group of students on all of the relevant policy documents to see if we could understand the integration of these 4 focus areas as fed into these 4 different guides, independent guides for each focus area, and through the Engineering of Defense Systems and the System Engineering Guidebook. And so, you know, they all got to choose their favorite text analytic tool and use AI if they wanted to and come out. And so we found a really interesting thing out of that. All the policy is just as stovepiped as we thought it was. There's no integration across these areas that pops out of the language we're using. And we found other problems in that every one of these policies goes from a fairly general definition to specific jargon really quickly. And so you can't go through and say, here's how systems engineering applies to software pathway. You can go in the system engineering guide and they have an appendix about it, like it was a different thing. It's not integrated into the flow. And so we found out that there wasn't any real integration in this. And so this informed this idea of what does that workflow need to look like? And what's the essential workflow that we're trying to arrive at? And so after we went that, we started then, we let ourselves down on a focus and saying, well, you know, what are these artifacts? So what does a digital system engineering plan look like? Well, it doesn't matter. It looks sort of like probably what we have today, but it's really how you got it that matters, not what the artifact is. And we don't think those artifacts are going to change that much. And so we started talking about this. And so what we found is that the intent of all of these focus areas are actually centered around data and continuous evaluation. Fundamentally, that's what it looks like. So this idea of a circle started to form up. These 4 focus areas generate a layered, continual, and data-centered model with digital engineering as its core and its concepts, with Agile as its process flow, with modular open systems as its means to make sure that systems can be adapted and changed in the future, and with mission engineering to make sure that we integrate that across the portfolio level. And all of these things are driven by data, not independently developed models. And so we started thinking, well, you know, the artifacts are not important. It's really how we share the data across these different disciplines. And so data as a strategic asset became the buzzword. Richard Wallace at GTRI finally, out of all of this discussion, drew a cartoon that we just couldn't turn into PowerPoint because it's so good the way he drew it. And we started to look at it like this. So you know, the digital artifact might be a PowerPoint. You know, it might be a graph in a PowerPoint slide. What's important is the thing that generated that graph was a combination of human decisions and interlinked data. And it's always been that way. But what we really want to see is that interlinked data is not inefficient, right? It's not traveling sneakernet from person to person. They can go in and they can digitally connect it. So if I have a design review and I'm showing a graph and a PowerPoint and somebody says, change this variable, I want to see what happens, you don't have to take an action item and a month later come back with a study, right? You could just do it right there and it would pop right up on the PowerPoint. And this is the beauty of digital engineering and data transformation. That's what we wanted to get to. And so we completely changed our view of what a digital artifact was. as a thing that was produced or generated from the engineering ecosystem as a transformation of data and models into views, right? So any question you can ask should be able to be transformed that way. And it all seems really obvious. It just seems like we weren't able to arrive at that. So, you know, what came out of this is, so system engineering modernization is all about the process is seamless and efficient. Everything you're doing today in your digital transformation, if it doesn't make you more efficient, you shouldn't be doing it, right? And if you're hooking tools together and you're doing modeling and it's not making your process go more efficiently, you shouldn't be doing it. This is system engineering modernization. And I don't think this is necessarily the mental model that we all had. Some people had this, but not all of us had. It's got to make it easy to drill down from decisions to data and back up again. And we need improved interoperability and connectivity across this ecosystem, because I can tell you there's nobody right now that's doing a complete connectivity of the diamonds, the data and tool flow. So there's still too many human sneaker-based steps in the process. So let me check my time here. So once we had this in our hand, then we started thinking about, well, how does the processes flow through this? And this is where we got into this idea that, well, what we're really talking about is taking sources of truth and feeding up through a data transformation process to produce artifacts. And so we kind of drew it this way. So this is really what we're talking about. How do we regularly produce these artifacts through a data exchange that is a federated set of sources of truth? You know, there's never going to be one. It's always going to be different pieces of the program are going to have different sources of truth. And so we drew this out and realized, you know, this still doesn't capture the process, because this is an iterative process. It's not linear. We're going to do this hundreds or thousands of times in a program, so a big program at least. So we need to re-envision this, not as this, but as a circle. So we drew the circle, and we kind of understood that if you think of what we do, data has to get transformed through models into views that we can analyze and make decisions around. We all know this, fundamental engineering, right? And so those views are the digital artifacts that we're interested in. And the SE process models control how we manage our workflow around those view sets. And so we actually jumped all the way back to the learn, build, measure type of a methodology, because we start thinking of things as design processes like mission engineering. Well, what's mission engineering, right? It's a learn process, right? Fundamentally. So we flow around this circle, and all system engineering flows around this circle. And so what came out of this, we called this the bomb cyclone model, or somebody called it this. So this was simply an attempt to take all of the language around 15288 system engineering and all of the language around system acquisition and put it into one process view that circles around data at the core with model transformations out of the data feeding up into a process phase that produces a digital artifact. And those are still centered around milestones. The interesting thing out of this, if you go look about adaptive acquisition, the major capability acquisition, which you can't see at the top here, is the only one that really starts with define. Software and middle tier, they start with build prototypes. And then really we don't even have the process to define, but the sustainment side starts with measurement, right? So you can think of this now as, I want to draw something through this process. Mission engineering is going to produce a set of data and models that would inform needs and requirements. So that's great. They need to connect back in to that process, but test is also going to be informing needs and requirements. So the test models have to feed back in through the other side. The intel data, that's a measurement process, has to feed in digitally. So it's not a table in the back of a spec anymore, a volt table, right? It's going to be a MATLAB model of threat parametrics. That has to feed back in. And so you can start drawing vectors through this that define how we're supposed to interrelate any system engineering process and acquisition process together. And of course, that's a long way. So I got 2 minutes left. And so I'll just tell you the next step. So one of the recommendations that came back is we need to build these exemplar reference implementations. It's not cameo examples. It's what do the ecosystems look like as tailored by programs to meet their needs. And it's not going to be one. It's going to be a set of patterns that are useful. And so we really have to understand at the data transformation level how you connect all of these different environments together. So I think I'm probably at done. So what feeds out of this then is our next phases. And so now we have these lines of effort that we have to go do. So we have focused topics. If you think about how every process the DoD goes around the circle, mission engineering is a continuous process. It happens continuously. Prototype engineering is a continuous process. All these things are continuous processes. So how each one of those do that, how we're going to train people in a boot camp mode. And so we're working with DAU on that. How we're going to do things like standardization and engineering workflow, how we're going to perform technical reviews. Everybody's working on a piece of this. I'm not going to say it's not being done. We have to develop the lessons learned and body of knowledge that links them all together. So we have a set of things that we're still working on now that are going to come out of the next phase. One of those is a lessons learned database. We have a library of 600 lessons learned statements from people who have been working through this that we're going to put into a document or a model to categorize them. We found that there's really no ontology that describes the link between system engineering and acquisition and military doctrine, and the definitions are all different for the same terms. And so we have the folks at Penn State are using machine learning to derive a digital ontology out of those definitions. We're working on the workforce education and training recommendations. We're doing a thing where we're not going to rewrite the DoD policies, but we're going to try and write them in a different form to see if it comes out as a more step-by-step process. So we're going to look at some different ways that we might model the policy, and then in the end, create a lessons learned database. So we had a thing called SEMOD BOK. We populated an initial set of stuff into it, and then it wasn't funded for the next round. So then the outcome of this is going to be a body of knowledge that tells people how integrated modernized system engineering is going to work by the time we get here. So I'll stop there and ask for any questions.
Thank you very much, Tom. So while folks in the room are queuing up their questions, folks online, please put your questions in the Q&A. I'm going to start with the obnoxious question. If we have to be more efficient, how do we measure, how do we know we're being more efficient?
So we did a different presentation on the digital measurement framework. So how you know you're being more efficient is you watch your cycle times go down, right? And we can measure those things. So, you know, the time it takes and the amount of effort it takes for you to get from one decision to the next in a complex system engineering program is going to have to be the way you end up measuring that you're more consistent. And you're going to do that by tracking things like how many errors I had to fix and, you know, the typical kind of stuff. But that's going to be kind of the key measure, is going to be your cycle times have to go down.
Totally unrelated to your question, but I just thought that we should probably mention at least an aha moment for me as part of this process has been how central data is to everything. And how many of our tools, various tools use data, but use data in different ways and formatted differently, different titles, different, everything different, but talking about the same data. One of the goals of MOSA, one of the reasons that was started is to get out of vendor lock with that system, with being able to then be able to compete smaller sections of a system so that not one contractor develops a system forever and ever, and we can update it and upgrade it and repair it easier. But it has to get out of vendor lock. Data is another potential source of vendor lock. If your contractor has all your data and in a specific program, right, and you as the government have paid for that data, they can give you the data, but if you don't have the program associated with it, you may not be able to do anything with it. Data being central has to start becoming agnostic to the program that it's being used on. It's a key concept that was an aha moment for me as part of this, and I've been pushing it just about everybody I talk to. So just as a sequel or a sidebar to this.
Yeah, as a really simple lessons learned, you know, if you're an engineer, you talk about data as being parameters in your model and you put the range and the values in there. If you talk about it as a software engineer, you call it a variable and you link to the government's data, but you don't put it into your model directly, right? So these simple lessons learned on how to build things are going to be really important to us in the future. And so we're trying to collect all these things up, and it's of course it's an argument, but you know, we have to be, and in the outcome of this, because we've got another project looking at like, how do you contract for this? This is going to be really hard because we're actually contracting for the government and the contractor to collaborate around models in the future, not deliver them to each other, right? So this is going to be a fairly difficult cultural transition for us to do. So if I say you have to use the government data directly, it's not government furnished information, it's the government database in their cloud, right? That's what you got to use. You got to link to that. So this is going to be really hard, but it's the only thing that's going to make this efficient in the long term.
Hi, TJ McKelvey with the Navy. I love your bomb cyclone. I want that. My question is, there's 100 things from InfoSec to classification levels to, like, I'm working with a contractor that's outside of the DoD sandbox that just slices this up as we operate today. How do you overcome that?
So there's actually a lot of separate programs going on in that space, you know, including how to get trusted vendors to come in and look at our government, threat data in order to see it, so that when they're driving their research and development and building their innovations, they're informed by the threat. And again, I think we're highly focused on how we manage the multi-level secure architecture of our tools, but not as focused on how we actually share that data yet. And so we again have to figure that out. So all these are things that are going to be slow uptake drivers, and make this, I guess Phil Zimmer, when we first talked about this and we were talking about this transition, she goes, you know, we don't call it model-based mechanical engineering anymore, it just is, right? It took like 35 years to get modeling and mechanical engineering to be fully integrated. It's going to be another 20 years before we end our SE modernization process here. I think so. So we'll have to watch this evolve. And the key thing for us is to keep it in, you know, every decision we make that doesn't make the process more efficient is something that we should put to the side and find the ones that make it more efficient. That's our point of view.
Further questions for Mr. McDermott or Ms. Geyer? Oh. Sandy, I knew you'd have a good question.
I don't know if it's a good one. I talked to both Nadine and Tom over the course of the past couple of days. I'm interested in seeing how this plays out with regard to where we put our knowledge. We have I always talk about the naval digital engineering body of knowledge, and we have the digital engineering body of knowledge. Now there's the systems engineering modernization body of knowledge. I think most of our stuff, even though we call it, like we're in the indie buck, but most of the stuff that we're doing at the NavAir and the naval level with the DSET working group is MBSE, not necessarily the whole digital engineering thing. So I'm thinking the MBSE stuff might go there. I don't know. It's not something that I'm asking you to answer, but I'm curious to see over time, if we have stuff that we want to elevate to the highest level, where do we put it? Do we put it in the DBOC or the SE modernization BOC?
We would love, I think, between us and Frank back there, to probably have a discussion, because, you know, these bodies of knowledge are going to be really useful, and the governance of them is turning out to be really useful. And but there's no reason why it can't be one with separate sections, then
Agreed.
lots of them.
Yeah,
And so I think that evolution, and I think we've talked about this, so I think we would love to have your advice.
yeah. So if you could put it on Daniel's action, Daniel Hedema, I suggested this, and he took an action to have a jam session. And so you guys need to be invited to the jam session where we try and figure it out.
So we had a slide, I don't think it's in here, on the difference between digital engineering and SE modernization. And so digital engineering is about the use of modeling and data to cover the engineering process. System engineering is about how to make system engineering more efficient within that process. So we think those are actually two different bodies of knowledge, or at least they can be, but it sure would be nice if you could easily access them. Yeah. So that's part of our challenge. Yeah. And I guess that's my heartburn, because I'm on the governance board of CruiseBach and DEBach, and I'm like, this is great, it's the same tool. Don't reinvent it, make it all just be one, and it'll be so much easier for us.
All right, any further questions? Tom, Nadine, thank you so much for your presentations.